So very happy when we get to the panel. If you want to give me a hard time, please do. It will be a slightly out of date view, but there are experts in the audience who are closer than I am. So we're going to bounce in this afternoon and just go through a number of addresses, quite a wide range of presentations. I will be keeping people to time, so otherwise we'll be running on to the evening. I think everybody's got about 30 minutes from the start of this talk. So Bob, you're on first.
Thank you very much. So this afternoon, I've got about 20-25 minutes of pitch, and then I'll leave opportunity at the end. I've got 3 questions, 1 ask, and 1 job offer. And I know this sounds odd in amongst a team of both industry and military. Job offer, unfortunately, the job offer goes to the military people at the back end. You might be interested. So my first question: how many are aware that there is a sustainability, efficiency, and exploitation team in the Army? I would know because you tapped me up for some questions and some slides there. There is an organisation, part of inside the Directorate of Basing and Infrastructure. My job with the team that I run at the moment, currently, my to-be boss, Grant Kerr, who takes up post next week as the AH. I get up every day with the team and are concerned about climate change, sustainability, and efficiency across our estate. As I said, I've got a few slides here. We'll try and give you a context of what's happening on the built estate, the training estate, and a bit of the language of the CCNS community. This is very much trying to provide a vehicle of, we do it on the home base, we can do it on operations. And like many in this room who were probably not so grey, a little bit more hair, and definitely didn't have glasses, I've been in operations with a number of people in this room, and we have served and dealt with a number of these challenges we're seeing again today. So there are no real new lessons to be learned, I would propose, at the front end. So in terms of context, the scale and size of the problem. It is a big problem for the Army. As you'd have seen in a couple of presentations this morning, the breakdown of where our emissions come from across defence, where the lion's share of it sits for Navy and Air, they're predominantly focused around their platforms. Whereas the Army, a big chunk of our emissions and our challenge against our targets is on our estate. That's both the built estate and the training estate. You look there, the challenge is also about the age of the estate. And it's a well-known trodden path that we look at our estate and think, how the hell can we deal with this? When you look at some of the buildings we have to operate with, we don't have the luxury of being able to take all our 22,000 plus assets and level them and turn them into the modern design, efficient infrastructure that we'd love to have. We just cannot afford to do that. But what we can do is provide the guidance to the planners, those who are implementing, and also those people who are operating our defence estate within the framework of the Army. But we're also there as a C team to provide that advice, guidance, and share experiences across defence. And picking up a couple of the notes this morning, that bringing together what everybody has been doing is a significant challenge in its own right. But I'm pleased to say that we are getting better at sharing that information, sharing those lessons, sharing those reports, because lots of people are challenged to look at the same thing time and time again. But as I said, that's the scale and size of the problem. I'll pick up a point at the bottom. Commander 8, you brought up the point at the beginning of your opening address. Weaponising of energy and becoming a challenge to us. We are not immune in the Army estate from the increase in utility costs. We are staring down the barrel of a 40% hike on our utility costs alone. So Director of Basing and Infrastructure, General Richard Clements, is going to be presented with some significant choices to make, some really tough choices to make. Does he continue to invest that money on the estate, or does he use that money to pay the utility bills? We are not immune from this on the Army estate. Sorry. So you'll hear some talk about targets. So we have been set a series of disaggregated targets by government. So that has filtered down from central defence targets and then they've been disaggregated to the respective TLBs. We own the responsibility for those targets. We own the responsibility of providing a strategy to get after them. Some of them are quite racy in terms of the timeline and what we are seeking to achieve. And I make one example here of our reduction of water as an example. It's a commodity we need. We can't survive without it. But we are pressured all the time of our use of water on the estate, whether it's to consume it for drinking, or we're using it to wash down our vehicles. And it was only brought really to light over the summer months, as we've all experienced the hosepipe bans, the temporary user bans that we all have now suffered under this country. The MOD estate is exempt from a number of those, but General Richard made a positive action to write to all heads of establishments and commanding officers to say you must act in a responsible way because you're a member of the local community. Therefore, driving behavioural change into the way we were doing our business on the estate would start to show an impact. And I can pick up later on some of the challenges we face with water abstraction alone on our estate now, which has been impacted, or we are relearning the lessons we had from the likes of Afghanistan, where we were drawing a significant amount of water for potable needs. So this year, launched at the beginning of this year, was the Army Estates Climate Change Sustainability Directive. Within there are 4 lines of effort. But what we need is to work together, both with the policy. Great, we've got somebody from the policy sector here today, because policy helps us unlock not just how we engage with our other TLB partners, but also our delivery agents. For example, in the Army space, the Army infra space, our delivery agent is the DIO, the majority of the part. So it's laying out that policy, so therefore when we are proposing to them the changes we want to make to these states, make it more sustainable, make it climate resilient, they are absolutely wedded to why we are doing that, because it's inculcated, it's embedded within policy. The people, and this comes back to not just the people who are building the knowledge base. So, 9 months ago, I was here in Chatham as the Chief of Staff. I didn't really know much about this. I've had an accelerated journey of understanding the language of a CCNS individual, understanding the hierarchy within defence, who is responsible for which part, who's going to unlock policy for me, who's going to provide me in wider government money to support some of the pilot activities I want to do. And that's in part what the C team does, is piloting activities. And those from the military in the room, think about the C team as the trials and development unit. So we're working at the vanguard of what Basing and Infrastructure is trying to run out through the respective plans. Partners, we need to work with our partners, and that's not just industry partners, but our international partners as well. So looking across the pond as an example, the US have pumped a significant amount, even off the back of the last government administration. They've actually put a lot of money into research, and therefore we can bounce off that. We can learn from what the Americans have done on both their military built estate, but their operational estate as well. And then finally, it's that funding. It's that unlocking that challenge that, as I said, General Richard suffers on a yearly basis of where does he invest his capital. And if you think about the infrastructure plan alone is £1.5 billion. In order for us to get to net zero by 2050, it will cost us about £4 billion. And I'll explain in a little bit how we get to that magic number. So there's a goal, there's a big challenge there to get between 1.5 and 4 billion. But we can do that by maximising our exploitation of government central funding. And we're doing some of that now in an early stage with partnership with the DIO to get after some of that additional money. But we do have some limitations, and they're fairly self-explanatory. So you'll have seen the diagram on the right-hand side, the hierarchy. It's called the carbon hierarchy. If somebody says to me, right, Bob, what should I do first? I've got this building. What do I need to do? Well, first of all, you need to make it as efficient as possible. Simply insulate it. Now, that's not going to solve everything, but it's going to make it a significant, easier challenge to get after drawing your carbon emissions down. If you can insulate, you don't have to heat or cool it as much. Replacing. So the replacement, using renewables. So you'll hear a term, decarbonising heat. Simply termed, that is taking away the use of fossil fuels to create heat by electrifying your heat system. And the final one is removal. So that talks to our ability to remove our carbon from our estate, and therefore sequestrating, you'll hear the term sequestrating. It's using our natural capital to sequestrate that carbon. Picture paints 1,000 words. When I came into the job as the plans officer, we didn't really have a coherent picture of what we were doing as a C team alone, and therefore our ability to transmit and articulate what we were doing, and therefore gain that assistance we need from industry and wider defence. So a quick scan around. These are currently the in-flight projects that we're dealing with in the C team alone. The segments and sectors refer to the lines of effort, and the size of the sector refers to the scale of effort that we're putting into it at the moment. Pick a couple. So you will hear a term Prometheus, solar PV farms. Everybody says, well, why don't you just put solar farms everywhere? Well, actually, what we are doing within the C team is under Prometheus Wave 1, 4 sites. We've got 1 up online already at DST Leconfield. We've got another 3 coming online this year. What we are doing is de-risking the Army and the defence delivery of solar PV installations across the wider estate. Because if you can understand the challenges of what we do on the defence estate with solar PV, for that scale de-risk to 70+ sites that we're looking for Prometheus Waves 2 and 3. But one of the challenges is when somebody says, why don't you just put PV everywhere? Well, actually, we don't necessarily need that electricity in the summer months. What we do need, coming back to decarbonising heat, we need it in the winter months. So interseasonal storage, and the term is interseasonal storage, is about saving that energy generated for when you need it. So we've got 2 projects in the line. One is looking to put a battery in alongside our DST Leconfield PV farm. And then we've also got Project Store, significant funding by Defence and Army innovation money to look at interseasonal storage. We haven't defined what that is. We've left it as broad as possible to allow industry partners to help us unpack that. How do we store the energy we generate? Swinging around, talked a little bit about geothermal this morning. We are very fortunate in the Army estate. We sit over some very hot rock, in broad terms, across the south of England. So we are in a very good position to launch, as you have heard, government's initiative to go after this as another renewable source of energy, whether it's for heat or it's for power generation. The challenge we face is funding that initial exploratory work. And therefore, we're looking to engage with the likes of BEIS and central government to fund some of that early work. But it's looking positive. But what we need to do is make sure we're working across the TLBs, because everybody else is looking at the same thing. I know Air are looking at that for at least 3 of their locations, and Navy, certainly on the south coast of England, are on some very good hot rock. So it's making sure we're spending our money effectively and efficiently across defence, and we're sharing that best practice. Along the bottom, climate resilience, we are doing some work that's looking at how we can assist one of the other government departments, Environment Agency. They're looking to offset some of the work that they're doing further down the south coast of England and helping us to redevelop some habitat at Thorney Island. So that's a really positive interaction across government. But Thorney Island has another problem in terms of sea rises, and actually, if you look at Thorney Island in 2040 in the modelling, it's going to be underwater. So I think we need to waterproof lots of their kit unless you do something about it. But that will require significant capital investment to stop Thorney Island flooding. Land management, look at our training estate. In terms of what we do, we own the Army, responsible for the training estate. It may surprise you, but we're actually a net emitter to the tune of 165,000 tonnes per annum of carbon equivalent. Why? Because of the way we manage our land. You think about our tenant farmers, what they farm, cattle, etc., and all the things that go around to actually operating that part of our estate. It does cause us some issues, so we're looking at how we go after that. Microhydro, this is where we haven't looked at something and then realised at the moment it's not economic to go after it. So we've done the feasibility reports, we've looked at where we can do microhydro on the training estate, but we pared it back at the moment and said, look, at this moment in time, we haven't got the resource and the technology at our scale is not efficient enough. And the final one is water. Talked about it a little bit at the beginning. We need to get better. We are currently under significant scrutiny by the Environment Agency about our extraction of water on the Salisbury Plain area alone. We're reliant on the boreholes into the aquifer. That is putting significant pressure on that natural resource. If we break it, there's no other way for us to deal with that problem. So looking at measures by which we can reduce water, both consumption, usage on the estate is absolutely paramount. It's one of the new projects we're about to launch this year. So we talked about getting to net zero by 2050 and how much is it going to cost? How long is it going to take us? So we've conducted 2 particular studies. We've looked at Perham Down. That's how much and that's how long it's going to take us. That's one site. Knowledge it's a PFI site as well, so it's been reasonably well invested in. We've got a reasonably good understanding of the data because it's well maintained in terms of monitoring. But actually, it's going to cost us about that much. But there are some interesting developments on Perham Down alone, looking at wind generation. We currently don't have we don't have wind generation on the MOD estate. Actually, we're pursuing that now because of the restrictions have been lifted on planning permission. We're now looking to, can we start putting wind turbines? It means we have to engage with our, certainly with Air Command to make sure that those deconflictions are done. But opportunities arise both at Perham Down, so Salisbury Plain, Catterick, definitely, DST Leconfield, up the northeast coast. They are all viable options for wind generation, which is really interesting and hoping to go forward with that. I should have put this really up front. This is the 101. This is what you should be doing, all of you. Understand, there's a lot of good work that's been put into these documents. Get to pick these up, and I would say particularly for the infrastructure people amongst you, picking up the second from the right, definitely read. That's a very easy read, been well crafted, put together. But understand the language, and then looking at Project Terror as well. So that's the Army Climate Change Sustainability Directive and the challenge. I talked about behavioural change. We touched on it a couple of times this morning. Getting our people to do the right thing has always been a challenge, particularly when they don't pay the bill. Trying to get people to turn the lights off when I don't pay the bill. We've all suffered this at home, trying to explain to my kids why I should turn the lights off. Trying to bring them into the kitchen and show them the smart meter. And I've actually done to the point where I've shown them how much it's going to cost us more from next month when the utility prices go up. And it starts to get them in this cycle of looking at things. So they try and work around the house. What's consuming the energy? And then from the wider defence, there's a really good network out there of people, SMEs, and engagement opportunities. Whether it's listening to seminars, podcasts, etc., they're all there and available. And my penultimate slide, we talked about incentivization. So DB&I released about 5 months ago the Energy Efficiency Incentivization Award. Two strands. It is looking at our energy reduction across the estate. It is looking to reward financially through the LIFT fund. So the LIFT fund is a fund that's given to all commanding officers to improve the lived experience of their people. He is willing to put his hand in his pocket and give extra money to people who have driven, through behavioural change, a reduction in their utility costs. But also recognising through an award scheme, so giving people that tangible, whether they are a gold, silver, bronze, or platinum award, so they can show recognition for what they've done. So my ask, sir, when you are out and about visiting your units, can I ask, one of the questions you ask is, do they know what their utility bill is? And what are they doing about it? Because General Richard has written to all COs twice now. He's going to about write at the end of this week again about this and looking at people's behaviours around heating, etc. So, sir, if I could ask you to do that one thing for me, because it needs people to engage and get involved in, but understand is the critical thing. And finally, touch on the operational space. It would be rude of me not to. There are 2 questions in this. I've always had this on operations. How much power can I have? How much power do you want? How much power can I have? You look at Afghanistan as a really classic example where we wasted our power consumption. Team 528 Power, when it used to do an audit every 6 months, called up Faraday, they go around the totality of our deployed estate, something like 140 odd locations across Afghanistan. and they'd survey and look at all the generators we had. And it was eye-watering when you looked at the total. I can't remember the fleet number. It was in the hundreds of FET generators and cap generators we had. Less than 10% was operating at 70% load or above. For those generator ninjas out there, 70% base load is what stops an engine falling over. Anything below that, it screws the system up. So yeah, understanding the requirement, and Adam, I know this is the one challenging you, how much power do you need to provide and what blocks and sizes and scale and demand? Because everybody wanted resilience, everybody wanted to own their own power. And those are my two final questions in terms of us as both military and industry partners. Do we understand the materials we operate with and we design with and we build with? I loosely call myself a classic man in shed engineer. I'll just build with anything I can find in a skip. But I do understand the engineering principles that allow me to build it safely. And that's the key bit with materials. Understand where they've come from, understand the limitations you have. And then the final one, when we come back to commanders, and this is an experience we learned from our American colleagues, American US Marine Corps 2013, Green Fog, they challenged all their commanders to reduce their carbon footprint. And they incentivized them with the fact that their score on their respective command exercise would be measured on how much diesel they consumed. It drove significant behavioral change and getting away from finding these things in every command post. If you go into a modern divisional headquarters, you will see these things everywhere. Actually, going back to basics, getting rid of these power-consuming things drove that behavioural change. Hopefully, it's not been too much doom and gloom. My contact details are there if anybody would like to pick up. I'm here for today and tomorrow. And my final offer, come January, I'm liking to offer up to 6 months secondment for an individual. I'm going to set a rank bar at SO2 and below. Sorry, some of the front row, to come and work with the C team. And why do I say that? I want to build that KSC within both my team, the Army, and wider defence. And you can only really do this if you're given that time to focus on it. So I'm looking to reinforce the team with individuals on a rolling 6-month basis to underpin some of those projects. Mr. Casper, no, sorry, nice try. So yes, there's my contact details. I'll be putting some information out there later on this month.
Good stuff. And for anyone who wants to challenge the Army plan, obviously Bob's going to be on the panel later with his questions over there, so we'll get that challenge chart. So I find that really interesting. So thank you very much. So we should have staff calls. Look forward to this. Further challenge. Thank you.
Good afternoon, everyone. Staff Hawes from 2-3 Parachute Engineer Regiment. I'm delivering a short brief on designing for the vernacular, humanitarian aid, reconstruction. Urbanisation, population growth, climate change, contributing factors to the increase in the likelihood of people and its significant risk of environmental disaster due to inhabiting these unsuitable areas. These unsuitable areas, such as volcanic, seismic, low-lying coastal regions, are prone to extreme weather events and are more likely to be more frequent. Effective mitigation is paramount to reducing the impacts of this climate change and reducing the likelihood of instability and conflict that may cause humanitarian, economic and geopolitical tensions. The implications of the changing environment will be more complex and contested. Therefore, there is a more significant requirement for defence to support humanitarian assistance and disaster relief on HADAR operations. Defence may support these HADAR operations by utilising niche military expertise and subject matter experts such as security, crisis response, strategic, operational, tactical logistics, assets, medical health structures, infrastructure, and construction, technical engineers, and the use of communication and IT systems. Within this brief, we're going to look at the requirements for sustainable shelter design on humanitarian aid reconstruction. Shelter requirements pose a significantly complex challenge for governments, humanitarian agencies, and directly affected populations. Shelters provide the user security, personal safety, and protection in the environment and resistance to ill health and disease. Therefore, the expertise of construction specialists is required to respond to technical issues and promote sustainable approaches to building resilience to aid the survivability of those affected. International Federation of Red Cross define 4 different types of shelter through emergency, which is the initial response structure for those affected, providing them the protection from the elements. Temporary, a more sustained building that can offer further protection from the elements, but no longer than ideally 30 days and definitely no more than 90 days, because at that point they want to be looking at the transition process of moving them into more core shelters or permanent housing, whereby a core shelter might be a singular room that can be extended or enlarged for that permanent housing for the affected family. Factors associated with the shelter construction then on HADO operations. Time. Recovery projects should be completed as quickly as possible to minimise the impacts on the affected victims. In addition, the reduction in recovery time is crucial to reduce the construction costs supported by the government or personal resources. Post-disaster recovery process in Sri Lanka actually identified the cost and labour of materials increased by 15 to 25% over the recovery time due to inflation. Funding. Due to the many damage and limited funds, communities affected by these disasters always have difficulties properly and promptly initiating their recovery process with the insufficient funds for reconstruction. The additional challenge regarding funding resides in the allocation of funds effectively and efficiently to satisfy the project's needs, which require wise and systematic portfolio management. Resources and materials, another common barrier with housing reconstruction, as shortage of required resources and construction materials is created due to the housing projects starting simultaneously, which creates an increase in demand, and since the natural disaster effects events disrupt the local supply chain systems and production facilities, is inherently adversely affects the procurement and construction resources. Many housing construction projects become suspended due to the lack of supply of stock material and then cannot fulfill the rising demand. The workforce. Inadequacy of the available skilled workforce during the construction projects becomes a decisive issue that negatively influences post-disaster reconstructions. This can be from lack of field staff's expertise due to those that are trained in delivering the construction expertise on the ground itself. The inadequacy of these skills may significantly reduce the quality of the construction material or facility. Therefore, effective planning, communication, and coordination through the involvement of national and local government provides a comprehensive approach to the systematic coordination of extensive planning knowledge to help to that dissemination of sustainable building for the reconstruction. Resiliency and sustainability then. The post-disaster period has been recognised as the opportunity to improve the quality, resiliency and sustainability to reduce the overall vulnerability of future disasters. Therefore, the practitioners need to consider the resiliency and sustainability to prepare for unexpected future events to establish the new facilities for communities. In addition, several factors must be considered in the post-disaster reconstruction process, which includes the transportation and accessibility of affected areas. As I'm sure most of you will know, sustainability is the holistic concept. It must encompass the environmental, economic and social aspects to assess design viability. Post-disaster shelter housing reconstruction poses a unique and complex number of challenges with no single process to follow. These challenges have been identified, as previously mentioned, the environmental, economic and social cultural impacts. It also has inconsistencies regarding technical performance and the lifespan of proposed shelter types and the shelter reconstruction stages. Countries and civil responders are likely to rely on the military more as these disasters increase in scale, frequency and severity in the future. Therefore, defence will need to develop further understanding surrounding the shelter reconstruction to facilitate more effective deployment of defence assets. Therefore, I've used in this study the life cycle assessment methods to evaluate these environmental impacts of 20 proposed transitional shelter designs that provide a method for developing and quantifying the material use, energy use and environmental impacts of specific products, services and technologies. This all in accordance and has been standardised by ISO 1440 and contains the 4-step process defining the goal and scope, development of the life cycle inventories, and impact assessment and interpretation. In this study, then, 2 types of shelters have been identified of the transitional and core shelters in 11 different locations worldwide. These locations were identified as Afghanistan, Bangladesh, Burkina Faso, Haiti, Indonesia, Pakistan, Peru, Philippines, Sri Lanka, Vietnam, and Nicaragua. The following construction materials were assessed: bamboo, bricks, concrete, steel, and wood. The following slides just give you an indication of the types of shelter that were situated in these specific locations. So first, we've got the winterized shelter located in Afghanistan with a build time of 3 days by a construction team of 7 people with an approximate project cost of about 820 Swiss francs. Bamboo frame located in Indonesia took about 3 to 4 days built by 3 to 4 people with an approximate project cost of 330 Swiss francs. Core shelter located in Bangladesh, a 5-day construction build by up to 4 people, costing a program cost of 1,800 Swiss francs. 1-room shelter, so this is your type of core shelter located in Pakistan, had an overall project cost per shelter of 1,300 Swiss francs. The transitional shelter located in the Philippines, 12 days and with a project cost of 2,000 Swiss francs per shelter. Core shelter located in Sri Lanka, 5 days fabrication with up to 3 people constructing at 600, relatively low, 650 Swiss francs per shelter. Steel frame in Haiti, reduced time build there of 2 days with an approximate cost of 4,300 Swiss francs. Steel frame in Indonesia was a 3-day build by 5 people, but had a significant increase of project cost per shelter at 5,100 Swiss francs. Steel frame in Vietnam, a 3-day build by 6 people with a £1,500 Swiss franc cost per shelter. The emergency shelter in Burkina Faso, a 3-day build by 4 people with an unknown cost on this one. And then, the tea shelter in Haiti, 5-day build by up to 7 people, costing an approximate cost per shelter 5,400 Swiss francs. Another tea shelter in Haiti with a similar build time. A larger build time because this was a prefabricated build off-site, up to 2 weeks on-site construction with an approximate price of 1,600 for the materials, Swiss francs, and then a further 850 Swiss francs for staff and supervision and the construction itself. Tea shelter in Haiti, again, another 3-day build with an extremely high approximate cost per shelter of 2,300 Swiss francs. And then Pakistan had a timber frame of low time time to build of 1 day with a construction team of 4 people, and again a low approximate material cost of 500 Swiss francs. Timber frame in Peru, again another low cost per shelter of 560 Swiss francs, and a short-term build. And finally, the transitional shelter in the Philippines, 5-day build with a comparatively low approximate material cost per shelter of 500 Swiss francs. In order to calculate the environmental impact of the buildings, it was necessary to know the amount of the materials required to erect one of the buildings and the distances the materials need to travel from the production site to the building's final location. The amounts and locations of the materials was determined from the following reports, which was the 8 shelter designs from IFRC and 10 post-disaster reconstruction shelter designs. The environmental impact of brick production outside of Europe, and also bamboo-based post-disaster housing units from the tropical and subtropical regions using LCA methodologies. All of these reports included bill of quantities, plans, performance analysis, and lifespan of the studied shelters. But in order to develop that life cycle inventories, the amounts were all converted to either mass, kilogram per units, and transport distance per tons per kilometres. These LCIs correspond to the production phases and the transportation distances for construction materials for each shelter. Two types of distances were accounted for: local by road and international by freight ship. And this was estimated based on the area of the country of study, and the relationship between a country's area and construction material transport distance was defined based on technical literature. The results from this category indicate that the impact per functional unit of the shelters varies widely, but the impact per functional unit is not directly correlated with primary construction material, in contrast with the steel-based shelters. Therefore, steel-based shelters present the results from the highest variation, with the Indonesian steel shelter having the lowest impact, and the Haiti steel shelter having the highest impact, as seen in the centre of that graph there. The concrete, brick, and wood-based shelters present a similar range of impacts, but with more minor variations between the results and the steel-based shelters. The bamboo-based shelters display some of the lowest impact levels per functional unit and the narrowest range of impacts. Therefore, these bamboo-based solutions offer the greatest potential for reducing the environmental impact of the studied construction materials. It's important to bear in mind that transport distances and the availability of the construction materials is critical, and the influence their impacts. These results show the appropriate design and material selection play an essential role in the performance of these shelters. Life cycle cost analysis is often used for the cost efficient solution for build design options. Although it's more often applied to the design phase rather than the environmental LCA, the challenge is similar to the data availability and the quality. Furthermore, the life cycle analysis of the building is extremely complex, as it includes such factors as the lifespan of the buildings, maintenance regimes for the different building components, and the cost of transport and construction materials from the production centres to the construction sites. For the transitional shelters, the complexity increases because these factors are associated with natural hazards. Therefore, unfortunately, it was difficult to determine the life cycle cost of the transitional shelters due to the majority of current costs and the available data not being too accurate. However, I was able to get estimated cost per unit ranging from 500 Swiss francs to 2,500 Swiss francs from the IFRC. The results of this cost assessment varied broadly, as shown on the graph. However, the 6 shelter designs result in less than 1 Swiss franc per metre squared per month value, which indicate, while 15 of the 20 studied shelters achieved less than 2 Swiss francs per metre squared per month. These values indicate no correlation between the material and the proposed function unit. However, the essential factor for assessing the category is the lifespan of these shelters, which can be determined the success of the reconstruction project. From the results on the graph, it's possible to note that 15 of the 20 shelters had excellent cost to lifespan relationships. This technical performance then assesses the 20 shelter designs technical performance by estimating the expected shelter performance for a natural disaster or hazard risk at each location. The IFRC defined that the reports 3 levels, low, medium and high, of each of the 3 different types of hazard: earthquake, wind and flood risks. The shelter's performance for each of the hazards was described using 3 levels in the report of the 10 post-disaster shelter designs, with green indicating that the structure meets the safety standards prescribed by the International Building Code, and however, and that amber indicates the structural system does not fully meet the requirements of the International Building Code. However, reduced design loads will not have caused the failure of individual members of the structural system. Finally, red indicates the reduced design loads will result in either complete failure of the individual members or overall collapse of the structural system. Therefore, the technical assessment category was subdivided into those 3 categories of flood, wind and earthquake, and they were assessed in the matrix that I've just described there. And the scores ranged from 2 to 6 points, with an aggregate values of 6 to 18 points, with the results presented as contributions to the performance of the 3 components, individually and also some on the graph on the display there. From this graph, it's possible to note that the 15 out of the 20 shelters achieved scores equal to or above the average of the whole category. Additionally, most of the shelters performed well in flood, earthquake and events, although most of the shelters suffered from low performance and high winds. This result was significant as the wind events, such as typhoons, hurricanes, occur periodically, or earthquakes and floods occur randomly. These results have identified that the shelter's technical performance is not perfectly correlated with their construction materials, as opposed to depending on the structural design used in each risk zone. For the sustainability assessment, then a benchmark system was developed in order to assess the sustainability of each of the shelter designs. The three categories, environmental costs and technical performance, combined to generate the benchmark system. Each category results are shown on the x-axis, and cost category results shown on the y-axis, as detailed on the graph. Results of the technical category are represented on the numeric colour scale, in which 10 points red is the lowest score, 17 points being blue is the highest. And in this system, the best performance area located near the origin of the graph and above 12 points on the numeric colour scale. The results have shown with high technical performance can be achieved low environmental impact per functional unit at relatively low cost, shown on the graph. And 10 out of the 20 shelter designs were located in the figure's best performance area with environmental values below 0.6 millipoints per metre squared per month and cost below 2 Swiss francs metre squared per month. Of these, 9 out of 10 of designs have scores above the average score of the technical performance category. To further validate these outcomes, sensitivity analysis of construction material considering the variability of the results was used. Shelters were grouped around the primary construction materials to understand around how the results would vary. 4 categories were defined: bamboo, wood, steel, and concrete/brick. The mean, lowest, and highest values perfect. So to validate these outcomes, sensitivity analysis of the construction material considering the variability of the results were used. Going over those 4 construction materials identified: bamboo, wood, steel, concrete/brick. Mean, lowest, and highest values of each of the construction material was calculated, and for the technical performance category, all of the construction materials could produce disaster-resilient shelters with above-average scores. The concrete-based shelters had the best performance in this category with the highest mean value of 14.2 points, and the narrowest variation of results for the construction materials. Bamboo and wood categories had the similar mean values of 13.3 and 13.4 points, respectively, with much wider variations. The steel category had a mean score of 12.7 and a narrow range. Further analysis of this environmental impact and cost categories conducted using a new benchmark with values from the categories as shown on the graph. And the graph shows that bamboo-based shelters have the lowest impact and cost per functional unit, highlighted there in green, and perform better than the worst. Concrete and wood shelters perform better than the worst bamboo shelters. This result reaffirms the appropriate design and material selection of vital parameters. In conclusion, then, this study of sampled shelters displays the proposed functional unit produces comparable results for diverse construction materials and shelter types. This method developed here allowed identification of the most promising material and design combinations to withstand local natural hazards, the lowest economic and environmental costs. These results show that the shelters with the highest cost or environmental impact do not necessarily perform the best from a technical viewpoint. Furthermore, no direct correlation between the type of construction material and shelter sustainability was found. However, proper design and material selection drive the sustainability performance of the study shelter designs. In addition, with global and local construction materials, these can produce sustainable solutions for post-disaster construction projects. Local materials having a higher potential for lower environmental impacts and cost, and global materials having a higher potential to produce better technical performances. The above results show that shelters with a high technical performance can be achieved under environmental impacts and per low cost functional unit, while local construction systems can provide best compromise between environmental impacts and cost, whereas the structural design requires more effort. Therefore, this study aims to contribute to the research and post-disaster shelter accommodation through case studies, empirical and technical elements, and theoretical conclusions. The comparison of the post-disaster accommodation in multiple regions presents a novelty since no studies compare how defence may adopt pre-existing shelter designs and implement them on future HADAR operations. Theoretical conclusions aim to define the possibilities of the standardised design solutions, which may be modified to meet environmental, economical, social, cultural, and technical challenges. The empirical side of the research aims to support these concepts in the design process by identifying current appetite of defence stakeholders. This research will also contribute to defining strategies that can guide future designs of post-disaster shelter accommodation and aims to bridge two areas. Firstly, the design of sustainable post-disaster shelters. Secondly, the process of post-disaster shelter requirements for military engineers. Additionally, additional recommendations are to utilise the IFRC transitional shelter designs as a base example for sustainable shelter design, and the utilisation of an LCA method by military engineers to enhance their post-disaster shelter design assessment. And this can be distributed through an ISCN to communicate good practice, but further research for social and cultural challenges required, especially during operations. To enhance our tradesmen at all levels, further construction, shelter construction and coaching skill sets to be enhanced and developed for them to deploy on these operations and create better integration with the populace that's affected. Thank you for taking the time and showing the time for me to deliver this brief. Thank you.
Great stuff. Really strategic impact as well. It will be on the panel, so if you've got any questions about the analysis or perhaps the tactical application of some of that work, it's nothing at the end.
Yes, I know. Are we good? Good afternoon, all. Thank you, Pete and the MOD, for inviting RA International to the conference. I'll do my best. And I'll try and keep it to the 20 to 30 minutes. My name is John Mitchell. I'm the Operations Director for RA International. I've been doing that since I left the military in 2008. I got a ponytail and drew a moustache and then decided to come back to work. So I've been doing this. I've been very involved in the sustainability aspect of the company since then. The presentation today is there we go. Reducing the carbon footprint on deployment. So probably close to many of you in relation to your operations outside of the UK. And for me, it's been a pretty key aspect of being able to facilitate that for our clients generally being UN, MODK, other governments in various areas across the world. Excuse me. The presentation today, Pete, you never briefed them. The presentation today will pretty much cover a bit of background on RA. Sorry, they didn't download the presentation. Do beg your pardon. Yeah, I think you're right. Is it on there? Background? Okay. It's really tiny and my eyesight isn't brilliant. But okay, so I'll have to refer to this. All right. A little background on RA. Cover some of the carbon hotspots that we have that we've identified, common knowledge for many of you. Look at the net zero and the sustainability goals, and then give you some case studies from our experience in Somalia. Okay. It's already been covered today that the UK is the first major economy to pass laws in relation to this, the global climate and sustainability leader in many people's eyes. RA International, we've been a subcontractor to Defence since 2018. Pretty much building camps, maintaining the camps. For this one here in Oman and Somalia, but we're also doing that for the UN in very many areas. Currently, RA is assisting with upgrades into areas that will reduce the CO2 emissions. We're doing this at Camp Shand in Mogadishu, and we've got some of the Tangam team here today to answer some of the questions later on when we're done. Well, RA International itself, we provide integrated facility management services. We provide construction. We provide pretty much the whole piece in relation to the supply chain. Each of them very, very important elements of where we're focusing our sustainment model. Okay, we pride ourselves pretty much in keeping sustainability at the top of our agenda. As part of this, we formalized our sustainability strategy in 2018, and we began measuring our carbon footprint in the same year. Our camps and those pretty much of the defence are very, very similar, have a very similar setup and infrastructure. So we based this presentation on from the findings that we had during our analysis of the carbon hotspots over the years. So looking at those specifically, the biggest emitter is energy. We will spend a bit of time looking at that into a little bit more detail. We'll look at food and drink from our analysis, which can contribute up to 25% of carbon emissions of a typical deployment. An area that is often overlooked are air conditioning refrigerants, and hence we will show just how important proper maintenance is on ACs in order to reduce the negative impact. Deployments often take place in places with no straightforward waste disposal methods, which is why reducing waste from the get-go is so important. And last but not least, it's worth noting that air travel also makes up a large part of emissions associated with deployments, not necessarily always for the military, but certainly for contractors sending all our staff out to various areas. This has already been mentioned. I'll just add a little bit more to this before we go into detail. I wanted to recap on the scopes of the emissions under the Greenhouse Gas Protocol. Scope 1, as you've heard, refers to direct emissions. That's from our own or controlled sources, such as burning fuel, generators, vehicles. Scope 2 includes emissions from the generation of purchased energy. Often deployments will have no Scope 2 emissions and will be categorized as Scope 1. Of course, Scope 3 includes all emissions from the value chain, such as food, drink, materials, travel, electricity, equipment, etc., etc. So energy, as already mentioned, energy typically makes up the largest share of emissions associated with deployments, particularly when it's self-generated, since these traditionally happen through the means of diesel generators. When energy is self-generated, it belongs to Scope 1 emissions, and it's something that the organization fully controls, which means it's an area with large potential to reduce impact. So in terms of us looking at reducing the impact, the first thing we looked at obviously is the power source. How is the power being generated? If it's through the diesel generators, has the equipment been properly sized for the power requirements it's serving, and is it being maintained properly? Secondly, is there any room to install renewable energy to serve a part of or give the full requirement of the camp? So I know this is bread and butter stuff for many of you here. Once the power source has been considered, the next thing we look at is energy efficiency. And here as well, the proper selection and maintenance of equipment is crucial to ensure energy is not being wasted. Common sense options that we've found in Somalia in a camp, our camp, include installing sensors, switching on the lights and or the ACs when someone enters a room, ensuring equipment is not left on unnecessarily, LED lights, replacing traditional lighting, and solar water heaters, making for great alternatives to electrical water heaters in locations that commonly have abundant sunshine. But also energy monitoring systems, we heard mention of some of that today, that analyze and regulate the energy usage, as well as detect and sometimes even automatically rectify power being wasted. Obi Shand in Somalia. We have a facility maintenance contract there, and over the last couple of months, RA has assisted Defence with research into potential upgrades that will lower the carbon impact of the camp while improving self-sufficiency and mitigating operational risk. After analysing the camp and its power requirements, we proposed a 160 kW solar PV installation on the roof of the headquarters building, covering its full power requirements, as well as the adjacent bunkers. This would not only lower CO2 emissions, but also provides Defence with an alternative power source, which mitigates operational risk, since there's currently only one power source, which would leave the camp without power if attacked or otherwise destroyed, which can happen in Somalia. It does also provide Defence with free power once the initial investment is paid off, and should the deployment end sooner rather than expected, the installation can easily be relocated to another deployment and hence become Defence's asset. There are also other considerations such as reduced noise levels and the fact that minimal additional space is required within the camp, since space can often be in short supply in these environments. Of course, that's then us looking at resilience and efficiency. In Obshan, the PV installation will save us an estimated 205 tons of CO2 emissions per year. It's the same amount of emissions caused by driving our cars for a whole year or by 25 million smartphone charges. In context, to sequester 205 tons of CO2 emissions from the atmosphere, we'd have to plant 3,390 trees, seedlings, and grow them for 10 years. Interesting. As I mentioned previously, AC refrigerants are often overlooked. So just to cover this in a little bit of detail, the reason that AC refrigerants require additional attention is normally a high correlation between emissions and cost, meaning that those things that cause high amounts of emissions are already in our radar, since they also come with a sizable price tag. However, AC refrigerants are a complete outlier to this, as they're very cheap while incredibly harmful if released to the atmosphere. For example, I think it's on the slide, yeah. For example, 800 pounds worth of refrigerant gas released to the atmosphere emits the same amount of emissions as burning diesel for close to 50 grand. To avoid these devastating effects, proper maintenance of AC equipment is crucial, and this is one of the core services RA offers as part of our facilities management service. We procure the more efficient inverter type ACs for ourselves and our clients whenever possible, and our expert technicians carry out regular and scheduled servicing. During this servicing, they capture the refrigerant gas using the latest technology. Using the latest technology to ensure no gases are released to the atmosphere. We also rigorously monitor gas usage in our resource planning systems to ensure we detect and address any potential leaks early. Hearts and minds, I believe, was mentioned earlier. Food and drink can account for up to a quarter of the carbon impact of deployments and counts as Scope 3 emissions, since these are emissions that occur in a supply chain. At RA, we have carefully analysed our menus and operating procedures and identified areas with potential for reducing the carbon impact associated with our catering services. We optimize our supply chain to reduce the distance the food has to travel and carefully plan our menus, portion sizes, and communication to ensure as little food as possible is wasted. We also vary the types of protein on our menus to decrease the carbon impact, and all of this while ensuring a healthy, tasty, and balanced meal served to the client to maintain morale, of course. Waste. Deployments often take place in places where no waste disposal methods are in place, and it's why that's important. Why it's important to try and reduce the generation of waste in the first place. We at RA have undertaken several successful waste education initiatives over the past few years, most notably through substantial water and sanitation upgrades at one of our most established camps. These upgrades have meant that our staff and visitors to our compound can drink Hawes standard potable water straight from the tap. This avoids 15,000 plastic bottles from going to a landfill every month. We recover the cost of the upgrades within less than 3 years, and the upgrades have also meant that we can now use treated wastewater for irrigation and flushing toilet, reducing our water impact in an area known for its frequent droughts and water scarcity. In summary, it's a win-win situation for all sides. Sorry. Okay. I mentioned earlier of assets, especially in short-term deployments. From our perspective, looking at that, short-term deployments need not be forgotten in terms of reducing the impact on the environment. Not mentioned here on the slide, but here on my notes, with deployment of reusable assets, key planning in the supply chain, reducing dependency on fossil fuels with alternate and emerging technologies, and obviously design teams' considerations for incorporation into the budget models. This is the document that previous gentleman mentioned, and we're all probably familiar with this. For RA International, we've taken snapshots from this and identified clearly that you mean business, and that's quite important for us as a contractor to know that when you do what you says on the tin, you actually do it. And it's really good to see that here we are today across your contracting fraternity, your suppliers, and here clearly the MOD, that we're getting into some serious dialogue about it. In terms of RA International, we cover our own sustainability development goals, and clearly pointed out here SDG 7, affordable and clean energy, SDG 12, responsible consumption and production, and SDG 13, climate action. And we are really getting in amongst it in the areas in which we work, and not just Somalia, but also other areas in Africa and the Middle East. As already mentioned, we have a very ambitious sustainability strategy, RA, and have set science-based targets to reduce our emissions. Science-based targets are transparent emission targets that are in line with the goals of the Paris Agreement. And as previously stated, we like to pilot our new technologies and solutions before we go live and take them to our clients, and very much an important aspect of RA's work. In 2020, we installed a new solar PV farm in our own camp in Mogadishu, and the savings in the first 2 years have exceeded our expectations from the time of purchase. Rising fuel prices have furthermore meant that the system is paying itself off quicker than expected, and all this paints a very good picture for further investments by us as a company into solar PV for our own people. That's pretty much it. All our stuff is on the website, and of course, I'll send any questions on completion along with the Tangan team who have come to help. Yeah.
Regain that. Okay, I'm going to ask the panel to come forward, the speakers, join me in the front, please. What we're going to do is, you have a question that you hand up. I'll do a bit of on-time selection to my main contribution to the breakfast. You could stand up, say who you are, where you're from, that would be really useful. And then, as I said, if you've also got a particular question for one of the team, crack on. If you haven't, we'll work it out in front. Just give it 1 minute to get everybody up. Let's give it 1 minute. It's gone silent. We're going to crack on. Okay. Hold on. You're back up. Sorry. Okay. Any questions from the gang? We've got about half an hour, but let's see how we do.
Dave Vickers, Conrad Gate. So I'm interested in, to what extent, our Royal Engineer courses, be it artisan courses, clerk of works training, PQE courses, prepare our designers or tradesmen to understand carbon usage being through the use of infrastructure. So perhaps staff, can you, clerk of works, can you just give an indication as to how you found the clerk of works course, how well it equipped you to do that? Was that your thesis, was it, from your clerk of works course? Yeah. And sorry, and then perhaps Gary might give a slightly wider view for the rest of the DEW courses as well.
So I think for the sustainability piece within the clerk of works course itself, it gave you the fundamental exposure of it, but not in broad terms, but not specifics on how to calculate out what the different methodologies were, how you that building volumes, whether that's UK or CLC. It was only when I did a secondary dissertation on the course that we started to delve further into that. So it does take a sort of considerable amount of time to suggest that sort of information and to work out the methodology behind sort of the FCA process. But then ongoing, whether that can be implemented into the course, that's great. But it's quite a complex, challenging aspect of design. I think it's attention, essentially.
So, Gary, I'm the Chief Instructor for Professional Engineering. So, our courses are primarily designed to give the engineers first principles education in all aspects of engineering. Where we are aiming, they touch upon sustainability. The aspiration, though, is it's embedded into all elements of their training. So, rather than being you are talking about sustainability, each aspect, whether it's concrete training, steel training, the electrical mechanical stuff, each of the elements has the sustainability element built in. So it's really much focused on the first principles aspects of engineering rather than specific carbon cost capture sustainability.
Watched attention. Yeah. Okay. Thanks. Any more questions? Don't be shy. Yeah. Go for it.
Emmanuel from Defence Support Chapter. There's a question to both Colonel Rob and John for two different sectors, perhaps, in terms of what are the biggest challenges that we face in implementing what is proven and tested technology in the operation of the state, both from experience and also from your experience, John. You're using it in theatre and we're not.
For me, it's education. Really. But, I'm operating with personnel from UK, Western countries, developed countries, but also in Central African Republic, Somalia, South Sudan, where there is no government infrastructure associated with how they're going to tackle sustainability. And there's no knowledge why the workforce, what they should do, or what it is to do. So it's trying to change the best bits sometimes to be able to educate individuals who work with us. He might be a great carpenter, might be a great electrician, but he doesn't know outside of that. So education, my answer to your question is education is critical, and believing in it. So I'm the fossil. I mean, I was in this building in 1976. It's a long point. Using this problem, and I believe in my age, and that's what's going to be important. We're going to lead our boys and girls with a way forward.
So I think from a market perspective, it's the challenge of our delivery agent and the resource to go after our speculative pilot projects. As I said, the seating and what we're doing to the vanguard of what people are going to require today. But I think the resource is a challenge there, but we're getting through that now because DIO are investing this new one strategy thing now developed their own sustainability. So they realise they can invest both people resource and everything. The second one is winning the argument of balance of investment. And it's always been historical. Right, what's your payback, the Bob? About 30 years, if you're lucky, if it all good, nice and safe. That doesn't wash with balance of investment. Well, yes, we're now turning the corner where sustainability is seen as a marker on each submission. So one, you've got the ability to level that playing field and say, okay, it's not just about return on investment immediately. It's about de-risking and how you put value de-risking the wider program.
Yeah.
Can I make an observation or is a question? Right.
Do you want to say who you are so people don't know you?
Sorry, can I get an answer on Commander 12 Engineer Group and 170 Engineer Group? Very, very briefly. So I think defence, we talk of delegating, which is about delegation of money. But the argument is, the reality is, it's pretty centralised, and we're also getting into a central space when we're trying to get project or programs through on the home stage or the operational stage. So Dutch team, when they go out and design something, great, they can take something in, but they've still got to go through that balance of investment process. And somebody else owns all of the other details, and they know about what the cost of diesel is. The team that's designing are less aware of that, but it is the case that we're using area across in Mali. I think, in contrast, you understand your costs as a company. Absolutely, you are therefore incentivized to make the right decisions around what's right for you as a company in terms of your output, discernment to the outside world, but also on the cost-benefit terms, because you can see the payback. Whereas I think quite often in defence, we don't see the payback. I'm the head of establishment and powered by a police organisation to save money, but I don't hold any of the levers to do so other than changing behaviours internal to the establishment. I can't change radiators, I can't change light fittings and things of that sort. So really that's my statement. I think defence is quite a complex organisation in the cost to incentivise people to do the right thing. And just on the point topics of incentivization, the contracts that you hold on the operational estate, do you feel that you're incentivized to be able to offer the advice that you're giving to defence and whether or not defence is taking it? Because there are other mechanisms that would put the ball in your court, like in not.
That's an interesting question. I think we are, for the most part, but contracts are contracts where everybody is competing for a specific contract. And it doesn't matter what's into those contracts in terms of sustainability or best practice and better ways of doing something. You still got to fight with the other contracts to make sure that the cost is going to be acceptable. Plus, there's a contract under the Eco Garcia where the winning bidder is the lowest cost. So you put some amazing, this is an American run contract now. You can put some amazing initiative in there, innovation, etc. But you never know what the cost is going to be over the lowest emission.
So there is a light at the end of the tunnel. So you may be aware of a thing called an energy performance contract. It's effectively where you partner with an industry delivery engine and you agree a set return over a set period. When we MOD pay for that, it's a guaranteed return on driving down your utility costs on the site. First one going through starts this year and starts seeing delivery next year at Sanitation. So that is at the vanguard of what defence is doing. It's a model that's done across the rest of the government, and the government departments do it already. We haven't done this previously. It may sound a bit like PFI or PPP, but it's different because you're setting a fixed term and a fixed return.
That kind of attitude.
I think the other thing, if I may, binding into contracts is good contract writing. So actually much more we're seeing, and I speak as someone with both sides of the fence, incentivization from in the kind of partnership approach, so you get knowledge transfer and skills transfer built into the contract because both sides are experiencing and learning. The continuity often may actually come from the industry side, just because they've been working in a particular area for a long time. I'm not saying it's always true, but there's a flow of information, and there could be a bit of skills transfer built into that contract. You'll get a lot of that incentivization and knowledge learning to continue the agendas going forward. But I hear your challenge before. I think it is quite tricky. It is a complex engine. And making sure you get what you want from it and can pull the right levers can be quite difficult. I recognise that.
A question related to that one, and runs actually, probably to staff and John, please to begin with. Although two good questions. So the balance between using a local workforce, a military construction force, take the phrase, and a bunch of UK contractors versus the materials that you choose for the types of construction tasks that you're going to ask the type of workforce to do. And then where you sit in terms of an operation at the early stages when it's all, uninvolved space. It's about innovation. It's about finding what you can find in terms of resources and cobbling something together, making sure it's safe. And then someone will come along, when you get a master driver in theatre, you know that the whole thing's gone wrong and everything's got to be a standard design. You've got to wait for the standard resources. Where you sit on that, the questions now. So for staff, it's really, did your work expose a kind of a balance between material choice and workforce choice? And then for John, I think it's more about innovation. So the long-term contracts we're letting in the UK now, facilities management, for example, the tender process, part of the scoring criteria, and a significant chunk, 20, 40%, if I remember now. 20%, I think, the new FTIS maintenance contracts, 20% of the scoring of the tenders was on innovation and what the contractor would bring to that party. And I wonder whether we are doing that in the operational space yet, because if not, we need to, and it's probably something for Stratford. But start first, then, John.
So I think there's an element of forecasting, because there's plenty of data out there now. So the company got hurricane season happening on speed, all the replacement smash. I think if you've got that latest data there, you can identify what materials you essentially choose from that site, whether you would have to bring them in, import them via air freight, sea freight. So it's a case of take yourself away from that and not jumping straight in because I need to do my issue here, I need to use this material, I need to use this type of system, construction system. It's having something on the shelf to give you a guide. I think at the moment it's probably not in that space. I've done operating in the Philippines team is very much get on the ground, have presence, not actually take a step back and look at what we provide, what we've got with us, and what's currently there. The Philippines, tropical climate, got a lot of current knowledge there, use of bamboo, whereas military engineers probably aren't having it. But we can help facilitate that work. It's not necessarily construction, but underground style, we help them facilitate getting material, allow them to give them the skill set, give them the potential to start the construction process, rather than just deploying with something on the shelf, because IFRC have these, and UK have reconstruction packs, whether it's top haulage, rope, buckets, all that sort of thing. But it's actually probably a waste of money to use that, take that to a site, because then potentially not going to end up using it, or if they use it, they can use it for maximum 30-day period before they then return back to their old skill set, which is materials there. I just think it's based on forecasting. That's what I'm drawn from that. Is how we have these ISTNs where this Peru, what sort of shelves can use there. It's Central Africa, what can we use there.
I think we have an organisation in defence that did intelligence.
Yes, so the time that what staff hasn't shown in his own glory is his presentation comes out in his big end dissertation, and in there he's got some lovely tables for sort of present that information he just said, and they could be caught quite easily on an ISTN. So just to give you a little bit of praise, which I'm not doing there, he's already created that work.
Okay. Any other questions? Yeah.
Sorry, just John on contracts.
Sorry.
Yeah, and
Definitely.
pretty much to say what Josh is saying, primarily when new technology, new innovation, and that has been part of what we're submitting to Module K, for example, then we hire for that, hire specifically for that, and that's where our education system comes in. We always
But you're not aware of innovation being in any of your overseas contracts?
Sorry?
You're not aware of innovation being in any of your overseas contracts, is it?
Yeah.
Sorry, just to expand on a couple of points.
So who are you?
And also on this area, but what time am I working on international?
Well done. Thank you.
Just to expand on stuff, I think we need to look at what we use once. I don't know what you're talking about, but it's not enough long to install 40,000 kitchen, but I think we use our international storage, different storage. You know, so we need to look at what's outside. You know, if we're underusing generators, which just costs us more to maintain, so this is not basically on these, and further, you know, submission stuff. So just to sort of, you know, chart from our age, but that's the program Stephen and they presented a lot of these options to defence. We look at it from a sort of, you know, we know the basic point of view, but they've been doing this and they've been showing this and put it on their routes, showing the solar potential scenarios, some of the best development. You know, program-based approaches 5 years ago, I haven't that from start. So we're looking at it now, but potentially we're going to undermine, you know, our own generated by using them sort of PV instead of sovereign place. But what sort of my question is sharpening their corner as well, incentivising us is where's the line drawn between longevity and operating base and doing what's morally wise and right against what's going on. We can install this now, but the return on investment will be 5 years. But we've got the appetite for that, we can't do it in time. Shoot myself and put myself against what we're doing.
Adam, something I and many of you wrestled with for a long time, which is infrastructure is our legacy in control. And the fact that when you deploy on an operation, you're going to be home by Christmas. You know full well you're not. You're going to be there for 3 years, 5 years, 10 years. So when, for example, in Afghanistan in 2008, I deployed with the team, we went and wrote effectively infrastructure development out of Afghanistan. When the noise was saying we'll be here for 10 years, we laid it all out, said it's going to cost you this many millions of dollars. It's going to take you 5 years to build, but it's going to return you X, Y, Z in terms of saving money on utility costs. took a flip of CGO saying, no, we're going to be out in 3 years. Immediately, tier 2 accommodation, tier 3 accommodation, so wet build, which is going to be so much more efficient, got completely blown out of the water overnight. So all that planning is predicated on how we're going to do that. The politicians don't want to say we're going to be there for 10 years. The infrastructure people know we are going to be there for a point where we need to invest early. And that's the challenge.
Sorry, Andrew Manning, Utilities Requirements Manager. Sir, I was just wondering, does the C team have any intent or is there actually aligning with the PROGs, the Army, in order to take advantage of those things like grid balancing for EVs, etc. Or green fleet?
I know I've got to roll my sleeves up and get across the Marston Road to go and speak to Deep Program, Deep Future, sorry, because we know that there's a bit of a train crash coming. As we decarbonise heat on the estate, and therefore rely on grid electricity, so our demand's going up and our infrastructure's not ready for it, then you bring on board electrification of the platforms are coming, but we don't know what side, when, and how. And the final one is our population of workforce. They are investing in electric vehicles. If you bring that all together in a horrible mess in about 2030, when you turn up to work and we all plug in at 8 o'clock in the morning and all the lights go out and all the electric grid price because we can't handle it. And I know that lots of the network providers are already recognising that our national grid is really on the edge of breakdown now. So go figure what we're trying to do on the defence estate is a real challenge because we don't be digging up the road 5 years after we built a whole new bunch of camps and infrastructure because we realised that we now need to put a whole new HV ring main in. Because what we designed for was expected for the to receive it.
Well, could you say something about the interface between basing and the ability to generate on the bases and the ability to offshore that within the UK? Because there's a challenge there that people might not be alive
Yeah,
to.
so Prometheus Wave 1, 4 sites. One of the sites, DST Leconfield, were already exported to the grid through a PPA, so effectively an agreement with the network, so they give us money back for the excess energy we generated in the day. However, other locations where we're seeking to do the same, rock barracks, where it's up, we want to do that, we need to upgrade the grid, just outside some camp, just £1 million. I can't get that past scrutiny and say, by the way, can we have £1 million to pay the network to upgrade so we can export? So there is there's a to and fro challenge of do we generate enough for ourselves and ourselves only? Would we generate enough because we're in the right place in the country to be part of that wider national network of renewable generation?
Please, yeah.
Chris, from Oxford. What's going back to what you were saying about the reinstated output Afghanistan infrastructure development plans? I think in hindsight now, it had been framed more in terms of knowledge and self-contained and protection. I guess it's just looking back retrospectively, but that's helpful and just,
But there was an interesting conversation at the time because of the threat through indirect fire. So Taliban firing rockets over the camp walls into our infrastructure, which tent is not particularly good. This is high explosive. So, for example, our international colleagues, our Australians, at Kandahar, went straight to tier 3 wet build hardened bunkers. Actually, the impact on their people is quite significant. You're stuck inside a bunker all day, no doubt for daylight. So they did actually realise there are impacts of doing that type of activity. So yeah, our drive at the time was to try and protect our people, and we were given still there, scratching his beard. He was with me on that actually, Gandalf's younger brother. It was trying to present that not just saving lives from having protected structures, but also efficient structures that meant we didn't have to do those combat logistic patrols.
Please.
KPI. If we're putting so much more into PV rather than the overstate away, what are you looking at for the short term, couple of days, yield? And what are you looking at the longer term, say earlier seasons?
So at the moment, on the firm base, so DST Leconfield online, we can put lithium ion battery container setup, fairly standard industry 2010. The challenge is the interseasonal storage. Now, that could look like anything from another bunch of lithium-ion batteries, but we know they degrade over a period of time, through to potentially generating our own hydrogen and our own hydrogen fuel plant to generate electricity on site. And actually, we could benefit from any excess hydrogen, even export. We know, once again, more like the challenge of EV rollout, the infrastructure is not caught up yet with development of vehicles. So if we want to have a hydrogen fleet, we need to be very much ready to a hydrogen network. Because you don't want containers of hydrogen coming through the front gate every day. We just couldn't sustain that. So the national infrastructure needs to keep up with that. We couldn't sit.
But just swaps basically on site, sorry. Yeah, right, so that's Roger's point. And the one thing we do have in defence, the army, is space, which a lot of people don't. We have lots of land. And therefore, when it comes to interseasonal storage, we can perhaps be more inventive with that solution than other people can, because we have so much space. I think Scandinavians, Norwegians, did they? Had 100 metres cubed of sand or something, which would be very effective. There may be other solutions that work out there when you have as much space as we have. I mean, if you think about it, every single one of our camps has a 50-metre strip of nothing between the fence and the first building, the entire perimeter of the camp, the counter-terrorism area. That's 50 metres worth of land that is unused, and it's probably even bigger when we go on deployed operations to keep an even bigger standoff with, where there might be an enemy, where actually there aren't that many enemies in the UK. So, there's a lot of land there that we could use for something.
So it's fine, some of the questions.
Oh, yes. Sorry again. What's the focus on photovoltaic rather than wind turbines on
in my inbox, one of my team is leading on the planning commission for wind turbines on the estate. So 3 focus locations, Down, Patrick, and Leamington, as early opportunities, because the listing of restrictions on planning permission, but also, see, we've realised over a period of time, from a defence perspective, ECMO particularly, actually it's not so much of a challenge. I have a bunch of turbines, they know where they are, we can deal with it. So yeah, and local governments are getting better and more, not relaxed, but more engaging on that opportunity. So hopefully, say a touch word. 12 months, we may see something on the defence estate.
Yes.
Mark Hill, I'm the senior lecturer at the RSC. I don't know any questions too, really, but we've heard a lot about EV generation, hybrid generators, and the like. And what I haven't heard is, where is the drive to insulate these structures and make them more efficient first? There are loads of programs about generators, and I'm not dissing them, I'm not dissing them. But I don't see anything about the nature of operational infrastructure better in the first place. And I think that's a missed challenge for industry to say we have a logistic version which is a carbon that we don't like. We want to make that as small as possible. And when we get to the other end, we want our buildings to be energy efficient, so we don't have to have a 300 kVA generator replaced by a 200 kVA plus 100 kVA light. So that is the kind of drive to make things better first.
That's your point, isn't it?
Look at Adam.
I'm not scared of it.
No, if you set industry the challenge, that's how much money I've got to spend, both for the capability, the output base, that's what I want. By the way, this is how much I've got to run it. Come back with the answer. So they could come back with the most efficient generator ever, but the shelter itself is very porous and not very good insulated. Or they could absolutely provide you the best insulated structure in the world doesn't only requires a small generator. The challenge would be, do we pay the capex for the shelter, very expensive, it sits on the shelf for 90% of the time, or do we have the lots of generators that are running efficient?
kind of a systems challenge, isn't it?
And it depends on what the focus of that procurement it is towards the sustainability.
And as I said in my presentation, we're relearning the same lesson. You know, I saw the photograph of Estonia and what NAPI is delivering in terms of the tier 2 accommodation. Many of this room remember kudos units in Kosovo and Balkans that they've got flat packed and shipped by Cyprus and ended up in the COP. You know, and therefore we've been here before. You know, that was a contracted solution provided, you know, that site camp in that location.
Yeah, just as you were talking about using hydrogen on site and the impracticalities of lorry loads of hydrogen coming in and to an extent also the impracticality of actually piping it in massive long distances. So what about making it on site, you know, in a green way, or is it utilising some of the restoring some of that sunlight effectively, not necessarily batteries, but in actually producing hydrogen to use in support vehicles or for power generation?
Yeah, I suppose it's the level of ambition of is it each site is a node. So if you look at our garrisons, we have a hydrogen node, objects that capture it and typical thing. Or do we spot to each location? So for example, at Rock Barracks, the far reaches of East Anglia, actually they've got a huge amount of use for hydrogen, but they've got so PV from it. So there's a trade-off there of where we want it is probably not necessarily where we can generate it in an efficient way. So yes, we've got to stay everywhere that we can put PV on. Might not be economic, it's not ground mounted, it's going to have to go on buildings, not in the right location.
Please.
Sorry, it's pretty late in the day, but just one question I really sorry, getting the deployed environment.
Yeah, so who are you?
Sorry, don't call for the DTE consultant. So the deployed environment, do you have any processes in place to actually measure, manage and mitigate risks in your supply chain? So yeah, were you able to control it at all, or was it just one of those things you just had to be off the cuff on?
So on the 2 points I did as a section commander, so I wasn't privy to that sort of process.
Right.
That's the case. Yeah. But I could probably say
Keep the job going. No, the reason I ask is, you know, when you work for private contractors, we get money for it. But you know, we're in the same position as you guys in that moment of time. Okay, we're not wearing green suits.
Yeah.
But yeah, we're just trying to sort of learn from the military as well. So I do a lot of work with NATO and the Germans, all the rest of it. They're able on it. Yeah. Sorry for the term. But in the Navy's not yet. But no, it really is a difficult thing, and that's why I think that's suppression. Thanks for.
So there is one around risk. It's not necessarily risk to the operation. It's a risk to reputation and an ethical question. So if you think about solar PV panels, where they come from, or more importantly, the base material, we've only just been through the process of making sure that through discrete scrutiny of all our supply chain, that we are not exploiting people. So the modern slavery exploitation is right through renewable technology. We know that because of where that raw material comes from, and therefore we've got a responsibility with MOD to check that supply chain. So you know, that's where we work with industry to make sure we ask you to check your checkers and check your supply chain. But it's becoming more apparent now.
There's specific working groups looking at supply chain resilience. We do those with General Hutchins, who's Director of Joint Support. Yeah. So feeding into the Defence Supplier Forum and the Blue Star Resilience Forum, we do workshops looking at source of origin, the ethical, the financial, trying to make supply chain more resilient. And in terms of the mix of power and energy, building on the back of this conference, working with Andrew's team on the 14th of October, we're looking at road mapping, 2024 experimentation for a low carbon base, probably around microgrids, and then when do the other technologies look to integrate into that. So Casper's got a link to it. It's free to attend. There's virtual and physical attendance. So if you wanted to take us on and look at where the base design might go and help fit that future environment.
Okay, we're going to have to switch, I think, and go into this. Can I thank the speakers for excellent briefs, also for the questions, so that was all great.
Thank you. I'm just going to steal 2 minutes of your time, and then we can all get ready for later. Oh, sorry, the computer's doing its own thing. I'm just going to your question about carbon recording. Do you know about the piece that's coming in at the end of this year, part of the Environmental Act, that our industry has to declare its carbon records and its supply chain records if they earn over, I think it's, is it £10 million, something like that, if they have an annual income? Now, defence doesn't have to record that. All our supply chain does. So we've got, don't have to do it for our projects. Everyone we buy something from will have to do it. So that will feed our future strategies.
So we can get the slow down costs in there, but almost no social responsibility and that type of thing. So making sure they've got the right balance of work.
Yeah. So it comes to me to give the final points of the day. Really, they're admin ones for tomorrow and later on this evening. But what I wanted to do is this conference has been brought by the Institution of the Institution of Royal Engineers Sustainability Forum and the Team Defence in partnership and the museum. You've probably never heard of us, and you probably don't know what any of us have done. So I thought I'd just give you a little bit of background on that. So the Sustainability Forum started 18 months ago by myself and a few others, because we wanted to make sure that military engineering was taking this into account. And we know defence is, but what we haven't been seeing a lot of, and it's come out in question today, is the operational side. What are we actually doing as military in Greenskin? I haven't got it on today. But what we're doing in that deployable field to make sure we're mirroring what the home base is doing on us. So we've been doing a number of different things over the last year. We've made a few calculators. They're available on the website, but transport, personnel ones, do you understand the carbon footprint of the decision to fly someone in the UK? So I've made a decision, I've told my management, is I will not fly in mainland UK. Don't care if it's work or personal, I will not fly anywhere. You want me to go to Scotland? Great, but I'll catch a train there. I'm not going by flight. Why? Because I can drive my car for the whole year for one return flight to Edinburgh. So that's just a huge carbon footprint. So we've made a calculator so you can understand that. Sending your bloke to a meeting by face-to-face, do you understand the carbon footprint of doing that? It's actually better to put him in a car and drive. Okay. So we've made a calculator for that. We've done one for freight. It's actually being used on Jeffries at the moment, where you put the freight of your project into the calculator, you put where you're going to move it to, and it helps you understand where you put your logistics points for that project, because you'll understand the carbon footprint of it. And we've done one recently to help with the energy crisis of people to sit in their office space and understand what the office space or the home energy requirement is, and then do an assessment next to it and understand where you can save on just doing different things in your house. So that's something we've done over the last couple of years. We've now, myself and Colonel Miller are working with the Construction Industry Council on their climate action plan at the moment, and we've taken one of their work streams, which is planning for emergency response. So we're working with the environmental agency, local resilience forums and others on how we can use what military knowledge, 7 questions pretty much, and put it into what they do to help them understand the impact of what they should be doing in response to emergency activities within the UK. Sustainability research, we're helping pretty much support people's research, give them advice, point them in, make connections with them, but also provide some sort of financial support to mainly Clark Works research. And then we're providing training packages. Myself and a couple of others wrote the training packages for PW. We delivered a training package for 170 last year, and we've been helping out with some other little training packages across the way. And we've been doing carbon studies. As I mentioned, there's 3 of them projected out there. There's a couple of them on our website. But we've just been looking at different parts of military engineering and seeing where we can reduce our impact by simple things. We've already mentioned 2 of them today, which is the cement one and the insulation one. We did one recently, which caused a bit of controversy. Sorry, I can't get my words out. It's been a long day. Which was about aluminium mining. If you don't know, aluminium is probably the single most impacted product in the world because of the carbon footprint of creating it. It's about 5 times bigger than the next product in the list, just because of the carbon footprint of creating it. So things like Class 30 trackway, the carbon footprint of one of them is astronomical. We can drive a tank, a Challenger 2, from London to Berlin and back for 125-meter section, the carbon footprint of it. Right? So if you just think of, should we buy more of that in the future? Probably not. We should be managed declining it and buying something else. Okay, because the carbon footprint of creating it is huge. So there's some of the things we've been doing as a forum in the last year, and we'll continue to do that over the next year. This is the way we like to do stuff. We highlight, we challenge it, we discuss it, we talk to things about questions, and that's the way we approach taking. So what we're going to do over the next year? Well, we're going to continue to do this. So we're going to look at the defence processes and see if we can make a copy or a more operational version of it. So at the moment, DIO and the SEET process as a military, as a sustainability assessment process, well, it's a little bit too complicated for ops. So we're going to look at how we can reduce it, change the connections in it so it works better for operations. We probably will achieve that by the end of the year. We're looking at part of that SEET process as well as the sustainability assessment strategy, but we'll tie into one of the questions Mark asked earlier on, is what actually is the minimum requirements for our buildings? What should be the energy footprint? How much water should they use? What's the aspiration we want to get to? Now, we have that for the home estate, but we don't have it for the deployable estate. So that's something we're going to look at and see if we can actually help defence work out what is that aspiration for the deployed estate. And that's it in its initial concepts, but we are working on that. Instilling sustainability into all military engineering training. That's a piece we're looking at the moment. We just this morning got a higher level back in from one Lieutenant General. I'm trying to get another 2. But if we get that back in, we'll then be pushing that on to Land Warfare Centre to say this should be incorporated into everything we do. It should be part of our training throughout the levels. And we'll see more about that tomorrow. And a task I've been given before I retire in 18 months is to write a design primer for operational camps. So using some of the things we've picked up from different pieces of research, different things we know, different things people are doing on ops, and actually writing a basic design primer for how we should be designing camps for our operations. This fits into some of the work Steve was talking about a second ago. We'll be working with others over the next year to put that design primer together. So they're just a few of the things we're doing as an institution. And if any of you wish to get involved or feed into that, please get in contact.